Okay, so let's try this again. We had some technical difficulties. We're going to go back with example 1, and we should still be trying to find the value of x so that our function equals 6, all right? So wherever you see an f of x, you're going to substitute in 6. So where do you see f of x? Left hand side. So where this is, we're going to put a 6 equals 2x minus 10. And this is where we have an equation that you learned back in chapter 3. Did that part get on there? So do I need to say this is something that you know how to do? Do I need to tell them this is like a 2-step equation? Do I need to tell them that? Okay. 2-step, chapter 3. Okay? We're solving for x. So I got to add 10 on both sides to get that out of the way. Bring down my 2x. 6 plus 10, 16. 2 times x. Got to divide so that cancels out. My x is 8. So the only difference in what we did here is the notation. When we did this in chapter 3, this was a y. It still means the same thing. F of x and your y have the same common goal. They're the same value. They do the exact same thing. It's just different notation. So we just solve for x. Now look at your example 2. Instead of f of x, I changed your function to h of x. Now, did I totally rock your world? I shouldn't have, because you're going to find out that your functions can have any name that they want to give it. It can be an f of x, h of x, g of x. The whole point is this function depends on your x. It changes as your x changes. That's why the x is always in parentheses. They can put whatever letter they want to on the outside. It's just a reference. So for example 2, here is your function, and we want to know what x is when h of x equals 16. So if h of x is 16, I substitute, set it equal to 2x plus 12. The rest is simple algebra from a chapter ago. I got to get x by itself, so first let me subtract both sides by 12. 12s are gone. Bring down that 2x. 16 minus 12 is 4. 2 times x, got to get rid of the 2, divide. So, for this function to equal 16, my x has to be 2. That's all it is. So when you see those problems in your next class, because that's what I'm going to assign them, this is what you do. You're just solving for x. Now, when you're graphing functions, it's pretty much the same as if you're graphing equations. We want to set up a table, and we want to graph. Now, I'm not going to go over any of those here, because we've been setting up tables since chapter 1. You know that when we set up a table, you have x values. Remember, that's your domain. Sometimes they give you the x values, and sometimes they don't. When they don't, do you remember what our default domain is? This is what I always use. Do you have to use it? No. Should you? Yes. Because I'm covering everything. I've got negatives, I've got my 0, I've got positive. Piece of cake. The only difference is this may say f of x instead of y. Or this may say g of x. Or it may say h of x. But you're still doing the same work as if it was a y. So when you're graphing functions, you make a table and you plot points. It's as simple as that. So, shall I keep on going, Miss Allen, or should we make another video? Keep going. All right. So, the next term on your notes is defining a family of functions. A family of functions. I always used to have fun with this when I used to teach Algebra 1, because when I think of a family of functions, I think about, families that are dysfunctional. So, it's corny, but that's the way I, like...
Cricket.
Sorry. Well, I won't. Just dysfunctional family. Okay. So here's your definition of a family of functions. It's a group of functions with similar characteristics. Now y'all know what you know what this means, sort of, if you can apply it to real life. You know when you see a family, sometimes you don't even have to know their last name, but the way that they behave or the way that they look or the way that they speak, you're like, is your mama Miss Jenkins? Because you know, because they have the same characteristics, they have the same personality, that kind of stuff. So when we talk about a family of functions, we're talking about functions or equations that have similar characteristics. Now there's several different types of families. We're going to stay in the linear family because that's the chapter is on linear functions. So your next sentence should say, linear functions all have the form f of x equals mx plus b. So you'll know that a function is a linear function because they're always going to look like this. Now, there's, like I said, there's other families. There's the absolute value family. There's the quadratic family, where they have a different general characteristic that when you see it, you can associate it with a certain type of function. So this is our linear family. That's what we're working with. And when we talk about a family, you know there's always parents. So our parent linear function is the most basic one, and that is when your f of x is equal to x, okay? Whatever your x value is, that's what your function will be. Very simple, very simple. We're going to graph it because I want you to know how to recognize it as the equation, as the function, and on the graph. So, shall I? Okay. Let me get my pencil here. So on your paper, I'm asking you to graph the parent linear function. You should have, just like I have, f of x equals to x. That's what your linear function is, the parent is. If we want to graph it, I have to set up a table first. So here is my table with my default domain. And since my parent function is f of x equals x, whatever my x is, that's what my f of x will be. So if I want to graph it, if x is negative 2, f of x is negative 2. I already started. I don't know if y'all can see that. If x is negative 1, then my f of x is negative 1. Or we can say y. No, we got to get used to this notation. It's f of x.
Why don't you write them on the axis?
Okay, so here's x. Can you see that?
Mm-hmm.
And f of x. There we go. Bam. When x is 0, f of x is 0, so I'm going straight through my origin. When x is 1, f of x is 1. When x is 2, f of x is 2. So there are my points, but since we're talking about linear functions, that means I have to have a line. So here is a graph of my parent function. It will always look like this because your linear parent function is f of x equals x. It is simply a line that goes straight through the origin. Okay? So if I say the term parent function, you've got to know what I mean. I'm not going to tell you that it's f of x equals x. So the next portion is comparing your graphs. If you have a family of functions, and in our case, our family is the linear family, I want to compare these functions to one another. And we do the same thing if you have, a family and you have siblings. You get compared to your older sister, big brother, second cousin, whatever. Okay? So we're going to be comparing our different linear functions graphically. Is that a word, graphically? Okay. So at the bottom of your page it says, when comparing graphs, and I'm trying to tell you how to compare them so you know what I'm looking for. Here's the things that you want to discuss. You want to compare the slopes of your lines. You want to compare if one is positive or if one is negative, if one is smaller or larger than the other, if they're parallel, and we talked about that in the last video, so you should be able to recognize by the slopes if the lines are parallel. You should be able to compare the y-intercepts. One is a negative intercept, one